Okay, we're back to start talking more about transformations. I just want to rewind back to example B here, trying to relate what we saw happen to the graph to its equation, just like we did in A. This moved right 3. I'm thinking that has something to do with this x minus 3 inside those parentheses, and the fact that it got wider, maybe that has something to do with this 1/4. Okay, our next learning target is, given a function and its graph, I can identify the transformations applied to its parent graph. A transformation changes the size, shape, position, or orientation of a graph. We will use the following words to describe transformations applied to parent graphs. We'll use translation, reflection, stretch, and shrink. Another word you will probably hear me say sometimes because other textbooks use it, instead of shrink, you could also say compression. Okay. We are first going to start with translating functions. Translating a function's graph changes its position, but does not change its size, shape, or orientation. Another word for translating or a translation is a shift. I'm sure you guys have heard that. You're just moving the graph around. It's not changing anything else. You're just moving its position. So I have two graphs here that we are going to identify the family it belongs to, and then describe the translations we see that have been applied to the graph. Okay, letter A, g of x equals the absolute value of x plus 4 inside the absolute value bars, then plus 3. So remember I pointed out in our parent function table this special point 0, 0, which is the vertex on our absolute value parent function. As we see in the equation and by the shape of the graph, this is absolute value. And how we can really easily see how they have been translated is comparing the vertex with its new vertex. So my original here has that vertex at 0, 0. Ooh, that's just beautiful. Okay, but my new graph has a vertex at the point -4, 3. So what has happened to this vertex? We have moved left 4 and up 3. Letter B, I see this U shape, which is a parabola. I also see my function, g of x equals the quantity x minus 5 squared minus 3. This is a quadratic. We know that it also has a vertex at 0, 0, and then some of the points we have found are 1, 1, 2, 4, etc. This is where this one starts. Well, now my vertex has moved, let's see here, to the point 5, -3. So it looks like we have moved right 5 and down 3. Okay, we have a reflect here. It says, can you see where the translations are represented in the function? So I kind of talked about this when we weren't in the two examples above. Do we see these numbers in the function, and do we see any patterns? So if I look at letter A, my left 4, I'm assuming came from right here, this x plus 4. So let's see, maybe this was my left 4. And then my up 3, must have come from this plus 3 at the end, up 3. In letter B, I went right 5. This looks like that might be where that came from. And then my minus 3 here, maybe that's my down 3. So it looks like when we're moving left or right, we have opposite signs based on what we are really doing, because in letter A, when we move left, which is a negative direction in the function, it said x plus 4, versus in letter B, when we are moving right, which is a positive direction, it said x minus 5. But our up and down kind of made perfect sense because in letter A we went up 3 and it said plus 3. And then in letter B we went down 3 and it said minus 3. So let's use what we just learned there. And it says, what do you think? Using what you saw above, predict the translations, and g of x equals the absolute value of x plus 2, then minus 1. So I'm looking inside, and it looks like anything that's happened inside the function or parentheses has moved right or left. And we just got done talking about how it looks like they're going the opposite direction than what they say they are. So if this says x plus 2, I'm going to think opposite. I'm going to think negative 2, and I'm going to guess that that's going to move left 2. And then the end, it says minus 1, and we saw that that kind of just made sense how we thought. Like in letter A, the plus 3 went up 3, and letter B, the minus 3 went down 3. So I'm going to say that this is going to go down 1, which if we really want to sound smart, we now know the vertex is going to be at 2, negative 1. So that's translating. Let's look at reflecting. A graph can be reflected over the x-axis or the y-axis. Reflecting a function's graph changes its orientation but does not change its position, size, or shape. So I have the function g of x equals negative x squared shown. Identify the function's family and its reflection. Obviously, we have x squared. This is a quadratic. And we can only say it has reflected over the y-axis or it has reflected over the x-axis. Remember that the parent graph is opening upward like this. So it does appear to have flipped downward, which would be over your x-axis. So this quadratic function has been reflected over the x-axis. Okay, let's try it out. We just learned about translations and we learned about a reflection. Looks like a reflection comes from putting a negative in front of our function if it's going to go over the x-axis. Translations happen by adding or subtracting something either in the function or outside the function. So letter A is g of x equals x plus 3. Our instructions say identify the function's family and the transformations applied to the parent graph. Now this is just a plain old x. So there's no power on it or absolute value, so that's linear. Then we have this plus 3 at the end. That's just like a plus 3 at the end here in letter A. So that must mean up 3. Letter B, we see we have h of x equals x minus 2 quantity squared. That's a big hint. This is a quadratic. Then I have x minus 2 inside those parentheses. If we look at our example of a quadratic up above, inside the parentheses when I had x minus 5, oh, look at, I wrote a 3 there. That should be a 5. I moved right 5. So if this says x minus 2, I must be moving right 2. Finally, letter C is k of x equals negative absolute value of x. So obviously the family is absolute value. And remember when we put a negative in front, just like here, it was a reflection over the x-axis. Okay, we will have one more video to do the last page.